everyone. In this lab, I'm going to be going through the instructions for a Mac for the first assessed computer lab on tables or frequency tables and graphs or graphical representation. In this video, I'll be walking through a practice problem, and I encourage you to follow these steps in Excel on your own as you watch the video, and then you will complete some practice problems which you will submit to the Dropbox in D2L. Okay, now let's go through the lab instructions. The first thing that you want to do is download the data file and save it to your computer. And you should rename it appropriately with your name. I've already completed that step. I have the Excel file here all ready to go. Now, as a reminder, make sure that you include a header on your first worksheet. Within that header, you need to include your full name, student number, as well as the lab number. Now, that was covered last week in the practice computer lab or the computer lab introduction, but I'll show you how to do that quickly now. So the first data set that we're going to be working with is the same one that we worked with last week, where we have CO levels in parts per million. In the practice lab, when we use this data set, we created a frequency table, but today we're going to take it one step further and create some graphical representations, so some charts to go along with it. Let's start with inserting a header. So you can use the page layout view like I showed you in the practice video, but what I'm going to show you is how to insert it another way. So if you go to Insert, the Insert group, and select Header and Footer, you can insert the header and footer in this way as well. Header, which section you type in, so left, middle, or right, but what I am expecting to see is your full name, your student number, and the lab that we're working on. So this is the computer lab for tables and graphs. So you can see while I was typing into the header view, my window went to the page layout view. We can go back to normal by clicking on the left view, and you'll see my zoomed in data set. You should also make sure that you rename each of the tabs within the workbook to ensure that the reader knows what information they're looking at on each sheet. So I'm going to rename this first sheet in context of the data. So I'm going to name it CO levels in parts per million. And what I did to edit that tab was I double clicked on it, and then you can click where you would like to add something in, or you can right click and select rename. So before submitting your document, you should ensure that you've relabeled all of the data tabs to reflect the information that is on the individual worksheets. So now we've looked after the administrative parts or components of the lab, where we rename the file, insert the required information into a header, and rename each of the worksheets. Let's carry on with the lab instructions now. Today's lab is about creating the frequency tables to represent the data set, and then taking it one step further, where we graphically represent the data set and frequency table in a graphical representation. Depending on the information that you're given for each respective question, you may need to generate the frequency table yourself. So that is the first step if you are required to produce it. In other cases, you will be given a frequency table that you can work with right away. But remember, to create the frequency table, we use the histogram function from the data analysis tool pack and add in, and you can view how to add that in the introduction lab. Let's quickly review how to use the histogram function to create a frequency table. So we have our data set of CO levels, and we're given apparent limits. Remember, apparent limits have gaps between them, and the gap between each of the classes is 0.1 in this case. We could individually identify which data points fit into each of these classes, or if we want to use the full functionality of Excel, we will need to have the lower and upper real limits of each of the classes. So again, we've kind of drawn out what these classes look like. So we have a class that goes between 0.1 and 0.3, and then there's a gap of 0.1. The next class goes from 0.4 to 0.6, and a gap of 0.1. And then we go from 0.7 to 0.9, a gap of 0.1, and so on. And what our goal is to do is to close the gap. So our initial classes have gaps and they're non-overlapping, but when we close, we're going to bring the one limit up and the other limit down so that there is no gap and they meet in the middle. To determine that middle value, we need to determine what is halfway between 0.3 and 0.4. We've gone over this in the labs, the previous lab, as well as in the lecture material. You can review it there. But halfway between, we have 0.35. The next upper and lower real limit will be 0.65 and so on. So we need to put that into Excel now. So remember that we said that halfway between 0.3 and 0.4 is 0.35. And then our next value will be 0.65. Now we have an established pattern. Since all of our classes are equally spaced, our lower and real limits will also be equally spaced, so we can use those two values to extend a pattern for all of the classes. And you can even extend it upwards by highlighting both of them, bringing your cursor to the corner to the fill handle, filling it up, and as well as for the real upper limits. So now I've determined my real limits for each of the classes in the frequency table, and now I'm going to use the histogram function within the data analysis functions to complete the frequency table. So hopefully you have already completed the practice lab from last week as we've gone over how to use this function. In the intro lab, we went over how to add the data analysis tool to the data group. So if you go into the data group and data analysis does not appear, then you will need to add it in. You should refer back to the lab introduction Mac video where we go through the steps to add data analysis into your Excel. We're ready to create our frequency table. So you want to go to data analysis, and the first function that we're going to use is the histogram function. So select histogram and say OK. And remember, so the histogram was discussed in lecture when we discussed graphical representations, and the histogram is a specialized bar chart where there are no gaps between the bars on the x-axis. And that's exactly what we're doing here. But right now we're just using this information to create a frequency table. So first you want to select the input range. The input range is the raw data. So you can select all of it and go back. So we can see the input range went from A2 to H6 in my data set. And that's all the data that we want to classify into each of the classes. Now, the next thing we need to select is the bin range, and bin range is Excel's way of referring to the upper real limits. So we can select those now, and they go from L3 up to L7. Because I didn't select any labels within my input or bin range, I just selected the values. I do not need to click the labels checkbox. Now I get to determine how I display or where I display my output. So the output options, you can see by default it will go to a new worksheet, but I actually want to put my output within the same worksheet. So I'm going to select output range, and then you can determine the cell or location where your output will end up. And because I want to just continue this table, I'm going to go over to N2, and this will continue the output within the same table. Now I'm ready to display the output, say OK. And you can see here that it's taken each of the values in your data set and put it into each of the respective classes. So there are 4 values between 0.1 and 0.3, 10 values between 0.4 and 0.6, 17 between 0.7 and 0.9, and so on. So now we've completed step 1, which is creating the frequency table using the data analysis. So far we've used the data analysis and histogram function, identified the input range, bin range, and output range, and then we've come up with our frequency table. So the next thing we want to do is use some formulas to calculate the sample size, so calculate n, as well as a formula to calculate the midpoint. So let's determine the sample size, or n, first. We're going to label it n equals, and we can even align this value so that so the label appears right next to the actual value. And there are different types of built-in functions we can use in Excel to sum values, but I'm going to use the sum function. And anytime you want to use Excel to make calculations, you need to start off with the equal sign. So we do equals, and then we can type in sum. And the way that the sum function works, you can either highlight a range of values or put commas between them, between the cell references, and you can see that we have 40 values. So I'm also going to use cell referencing to calculate the midpoints using the midpoint formula from lecture. So we start off with sum of the lower and real limits, so we're going to add them together and reference each of them using the cell reference as opposed to typing in the actual values, and then we divide by 2. So we can see the midpoint of the first class is 0.2, and you can double click to fill the midpoint for each respective class, and what it does is applies a respective formula. So lower plus upper real limit divided by 2. So now we have all the information in our frequency table that we need when we talked about in lecture. So we have our apparent limits, which are all the classes with an existing gap, which is what we use for discrete variables. And then we have our real limits, which are useful for graphing histograms or for continuous variables, and our midpoints, which we will use when we graph frequency tables using frequency polygons. So it's the bar charts, the histograms, and the frequency distribution or frequency polygons. We haven't created a percent frequency column within our table, and we could do so, but what we were using that for right now is to make a pie chart, and Excel will do it for us, so it's not necessary to create that column. So now we want to look at graphical representations in Excel. So using the frequency distribution that we created, which is step 1, you're going to use that table in order to represent the information graphically. So I'm going to take this same information from our frequency table and create the 4 charts that we discussed in lecture. So I'm going to start off with the pie chart, and then we'll also look at displaying it using a bar chart, histogram, and frequency polygon. So in lecture we talked about when you use one type of chart over another and how to label the different types of charts. And we're going to apply that same information from lecture here in Excel. So in order to create charts in Excel, we need to use the Insert group and the Charts group. Just so we can see how that looks on a Mac, we go to Insert, and you can see all the charts in this group right here. So the first chart we're creating is the pie chart. Pie charts display the percentages and are used to compare different parts as relative pieces of the total. And let's look at what we're going to do. So the type of pie chart we're going to use is the 2D option. And if you go to Excel, you want to highlight every bit of the bin and frequency columns, including the more row. So we highlight the labels because it makes creating the pie chart more simplistic and requires less extra steps at the end and manipulation. And we also want to include the more row, since this is the entire amount of information that was created by the histogram tool with data analysis. And we want Excel to recognize that this is a data that it created. So now we go to Insert. You select your pie chart and the 2D option, and then your pie chart is created. So this is the initial chart that Excel creates for us. So we're going to see and explore how to manipulate it further. We want to make it as effective as possible by applying the rules of thumb that we discussed in lecture. So when your chart is selected, you have some options for chart design as well as format. And both of those groups at the top pertain to your chart, and that's why they're colored differently. They're in green as opposed to black for all the other groups. So this is how we can change the appearance and the information that is displayed on our chart. Feel free to play around with the different colors and display options and formatting of your chart. But what I'm going to show you next are the minimum requirements for what you must do to your chart. The first thing we will address is how to label your pie chart. So we can see here that we have the different categories or bins of the data set representing each of the class intervals are color-coded. And so we'll change from having a legend that is color-coded to labeling it directly on each section of the pie chart. And we also want to make sure that our title of our chart reflects what we are displaying. You may want to relabel this as figure 1 or figure 2, and that's really a personal preference. But what you do need to say is what it represents. So we have the percent frequency. We also want to give it some context, and not just percent frequency, but also say of our CO levels. And the original data points that we have are given in parts per million. Now the next thing we want to do is change these data labels. When you go to the design or chart design group, we want to look at add chart element. Currently there is a legend showing, and we want to remove that legend and change it to none. If you didn't have a chart title at the start, we could change it to include one, or change the way that it's centered and overlay. But the other thing that we want to do is include some data labels. So in the data labels, we're going to look at more data label options. I mean, you could initially put something, say, in the best fit location. When you do that, all it shows is the frequency for each respective class. But if we go to the data labels and select more data label options, you will get more choices. So we don't necessarily need the frequency, because if we display the percentage, it captures the entire picture of what's happening with the total of sample size, so in this case 40 values. And some of the values are showing inside, some of the values are showing outside. I prefer to show them all in the same location, so all outside. And I should have clicked off here the category name as well, so we know what each of those points represents. So we can see that the category name that's being used is the bin number, and we can change that, and I'll show you how to do that later. But for now, just to summarize what labels we've included, it's the category name, percentage. The leader line shows us where they're linked up, and the outside end, so positioning them on the outside. So in the next part of this video, I want to remove this more label and the 0% that's associated with it, as there are no values in the more region of the histogram that was created by the data analysis function, so we want to take that out. Now this step is accomplished very differently than it is in the PC version of Excel, so watch carefully here. You want to unclick your chart and select all of your data, including the labels that were created with the histogram. Go to the Sort and Filter function under the Home tab. So you go to Home, Sort and Filter, go to the drop down and select Filter. And then when you click on the filter, these arrows appear, and then we can click on one of the drop downs. So for the bin, and because we don't want the bin for the more category, we can unclick that and then close filter. And now our pie chart does not include the more bin. Now we want to format the category labels, which by default the bin numbers are showing for these. So if you right click on your chart and you want to go to select data, and within the select data source from Excel, we can see that there is a horizontal category axis label selection. And right now, if I move this over, you can see that N3 up to N8 are being referenced. So N3 up to N8, which are our bin numbers. So we can instead select other values. So we can select the apparent limits instead. And we want to go from J3 up to J8. Right now our chart's in the way, so it's hard to see, but J3 up to J8 contain all of our apparent limits. And when we say OK, it will change the category labels on our pie chart. Now, referring back to our instructions, we can see that we've created our pie chart. We've changed the format and design pieces such as the legend, and then we've also changed the data labels, their location, as well as what's showing on them. And then we also changed them to include the apparent limits as opposed to the bin values. Okay, so now what we're wanting to do is to move your chart to a separate sheet within Excel. So looking at our lab right now in Excel, we can see we have our entire frequency table with the chart showing. And the issue with that is that sometimes, because the chart is shown so small within your worksheet, we lose some of the details and you can't see the intricacies of the graphical representation. So we want you to move all your charts into separate sheets. To do so, you right click on your chart and you want to say Move Chart. So again, right click on the chart area, select Move Chart. Sometimes when you click on things in Excel, you might right click on a different region of the chart. So you can see here I'm right clicking in different areas, and different options show up pertaining to that particular area. So when I mean chart area, it's the white space behind your pie chart. So if you right click there, we get the option to move chart. Now you want to select New Sheet, and we can call it CO Levels Parts per million chart. Now, remembering that I'm going to be creating more than just a pie chart in this lab, I'm going to actually change this to say pie chart and put the context in brackets, so CO levels, and limit what else is showing here. It's important that we know that it is the pie chart for the CO levels. So that's sort of the information for our pie chart summarized. You can play around with the formatting if you like select the title. You can increase the size of the title, the category labels. Again, you can increase them if you like as well. whatever you feel is appropriate, as long as it's a nice professional document. By convention, it's pretty typical to see the data label or tab first and then the pie chart. So you can slide around the order of your worksheets by clicking and holding and moving to the left or right. So here we have the data and then the pie chart. So now we're going to go through creating the other different chart types, and we'll go through them a little bit more quickly than I did the pie chart, but we'll go through the expectations and requirements for each of the types of charts. So now we're going to look at making a horizontal or vertical bar chart. And so just keep in mind that the way that these charts are going to look, they are bar charts with gaps existing between each of the bars. So we can see an example right here. Typically, these are best used for qualitative data. So if we have a qualitative information and we can list each of the categories underneath each of the bar, as well as quantitative data that was found by counting, which makes it discrete data, and it's more appropriate to have a bar chart as opposed to a histogram to include the gaps. So some tips: in addition to including appropriate title, the axis title should be changed to reflect the context of the question. So your vertical axis should read frequency, and the horizontal axis should reflect the context as well as units, but use the apparent limits for the numerical scale as we did in the pie charts, where we changed each of the labels from the bin label to the apparent limits. So let's do that now. So when I was working with the pie chart, I ended up using the sort and filter feature to eliminate the more row. But if you want to insert a frequency bar chart, I'm going to want to highlight all the data again, all the way down to more, and go to insert, and your chart type will be not the histogram, but you can see when you hover over it, it tells you what type of chart it is. So a column chart, you can click on that, and we want a 2D column chart. So we would like to change the chart to have appropriate axis labels and chart labels, and then change these category labels as well. So we can click on Add Chart Element, and we're going to insert a chart title and put it above. There's already one there actually, and we also want to put the axis title. So we want a primary horizontal as well as a primary vertical axis title, and then we'll edit those boxes now. So we should make sure that the chart title is more to do with the context. So frequency of the CO levels. Here you can choose to put the units or not. One spot where we definitely need to include units is in the horizontal axis. So CO levels, and that's parts per million. And the vertical axis should be labeled as frequency. Another option that we have with the chart is to add data labels, and you can add them centered within the bar, or you can move them so that they are on the outside end if you prefer. And what those numbers represent are the frequencies of each of the respective categories. So again, if we want to remove this more category, we go to Home, and we will highlight the data again. And you need to make sure that the filter option is selected. It's already selected, so we're good to go. You can click on the drop down for the bin, and we can unselect the more option, and then just close this. So you can see that it removes the column for the more category. And we also want to relabel these labels so they represent the apparent limits. Now to do that, you right click on the chart area, say select data, and we want to change the horizontal category axis labels. So right now those axis labels show from N3 to N8, which is our N3 to N8, that's your bin values, but instead we want them to show the apparent limits, which goes from J3 to J7. Okay, so let's highlight those now. We want to go from J3 to J7, say OK, and you can see that we now have the apparent limits being shown right on our bar chart. So notice that we're labeling these with the apparent limits, and there's gaps between the apparent limits, and we use gaps on the bar chart to represent those gaps between the apparent limits that are shown. Okay, now we're going to work on the other two chart types, but instead of starting everything over from scratch, I just want you to copy, so Control C, or you can right click and say copy, and then we want to paste this same chart 2 more times. So we'll end up with 3 instances of it on the same sheet. So we've completed the bar chart. Now we want to create a histogram. So histograms show the same information as a bar chart, but instead of using the apparent limits, we use the real limits where there are no gaps existing, and we show no gaps between each of the bars. So to make a histogram, we change the horizontal scale to the upper real limits, and then we're going to justify the horizontal axis and remove the gap width. So we're going to work from this second instance of the bar chart to turn it into a histogram. So we want to first of all eliminate this gap. So you right click on one of the bars, and then you're going to say Format Data Series. And you can see here that a gap width is identified, and we can put it all the way to 0 to eliminate the gap. Once you eliminate the gap, you can see that your chart really just looks like one giant big blob of bars that all kind of blend together. So it's a good idea to edit that so that it has some distinction. It's not a requirement, but it is a good idea. So we can actually add a border in. So under this Format Data Series, under the paint bucket, you can select solid line, and that's changed to a black solid line. Instead of using a line, you can also just color each of these a different color. So if you go to the Home group, you can select a color for each of these to be filled a different color if you like, to place some distinction between them. And that's really a personal preference into how you want the chart to appear. But those are just some ideas of how we can edit it. With our labels on the horizontal axis, we want to use them so we want to make them right justified and also use the upper real limits. So let's do that now. So remember before that we selected or changed our horizontal axis to show the category. So with the apparent limits, now we want to change them to the upper real limits. So you right click and say select data, go to the horizontal category axis, and I'm doing this quickly because we've done it a few times already. And now we want to use the upper real limits. So those are the same values as your bin values, so you can select either of those columns and it will put the appropriate values in. You can see I accidentally put more than one set of values in, so I only want from L3 to L7. That should work better now. So we end up with a single set of values, and we also want to right justify these values. The instructions for this in Excel and on Microsoft Computer is to go to the Home group, make sure that your data labels are selected, and then you would write justify it. Unfortunately, I haven't been able to find an appropriate substitute to do this in Excel on a Mac, so I'm going to show you my little cheater way of doing it. So what I do is I insert a text box, and I'm going to end up placing it over top of the data labels that are already there. Now, we want to make sure that the data labels that we create are the same size as the ones that are already there. So I checked previously, they were a size 9 font in Calibri. And then we're just going to type them all out. I'm just putting a couple spaces between them at the moment. And then we're going to take those labels, and we want to cover up the old ones. So we've created this new text box. So check out what the color is too. It doesn't appear to be black. It's just a dark charcoal. Oops. It's actually the text that I want to make that color. And let's put a white background on it. The reason I want to make a white background is that I want to put this right over top of the other labels. And now we want to adjust the spacing so that these real limits appear right on the boundary between the two classes, and the upper boundary and of the lower class and the lower boundary of the next class. So this is a way that I've accomplished justifying the real limits on a Mac computer. So with that said, if you end up finding a better way to do this, please let me know, as I would like to improve this video and my instructions. This is what I expect your histograms to look like and the level of detail that's required within it. So far we've created a pie chart, a bar graph, a histogram, and now we're going to look at the last type, which is a frequency polygon. So we're going to edit that extra graph that we created earlier, and the changes that are required to change it into a frequency polygon is to change the chart type to a line, and then change the horizontal scale so that it shows the midpoints instead of the apparent limits. So fortunately, we already found the midpoints in our frequency distribution table. But if you already had a frequency table that didn't have the midpoints present, you'd have to calculate them at this time. So now we're going to start off with our bar graph. We're going to right-click on it and go to Change Chart Type and select a line. When you do so, you can see that it changes to our frequency polygon. And now we want to display the midpoints as opposed to the apparent limits. So to do so, we right-click and say Select Data, and we're going to go to the horizontal category axis labels and select the midpoints. Now we say OK, and you can see that our midpoints are displayed on the chart. You might want to format this frequency polygon as well and remove the data labels. To do so, you can actually click on them and press delete on your keyboard, or I'm going to put them back in. You can also go to the chart design, add chart element, and go to data labels and say none, and it will take them off. Okay, so now we know how to create 4 different types of charts based on the same data set. We also need to consider which one is the best to use. Okay, in the case of CO levels, which are in parts per million, this is a measured value and is continuous in nature. And so either the histogram or the frequency polygon would be most appropriate in this case. So now that we're done the practice problem and going through each of these chart types, you need to complete the submission questions. You have 4 separate questions to complete. Each are based on a different data set within your data file. They're all due in the Dropbox in an Excel file on Friday at midnight. So question 1 refers to sheet 2. You need to construct a frequency table, and then you make sure that you label the size as well as the interval width, and put a text box to explain whether or not the raw data is qualitative, continuous, discrete, or continuous. And then we're going to get into a second question, which refers to sheet 3. In sheet 3, we're given the total provincial area by land class, and so you're going to rename it, construct a pie chart for that data, and then note, because you already have a frequency table created, you don't need to do that initially. Whereas question 4 is a larger question because you need to calculate the lower and upper limits, calculate the midpoints, use the histogram function, and then create 3 different charts. Make sure that you read all the questions and follow all the instructions given. And then in question 4, which refers to sheet 5, so remember, each of these questions refers to a different sheet. So sheet 2, 3, 4, 5, and sheet 5. You can adjust the size of it. Sheet 5 is for question 4. And you need to rename it, then decide and produce a chart graphically that represents the data. And you'll need to move it to a separate sheet. So there's some level of applying what is presented in this lab as well as in lecture to determine the type of chart that's appropriate, and then inserting a text box to explain why you chose that graph that you produced. So as always, make sure that you go through the practice problems at your own pace, pause and rewind and rewatch this video as many times as needed, and also reach out to your professor if you have any questions about how to complete the lab. And bring those questions with you to your seminar or lab times during the week, because chances are if you're struggling with this content, so are the majority of other students in the course. Okay, I wish you luck. Take care.